Okay, so after we have understood that all the three columns are important for building my final output, which is class, now we have to do some sort of data preparation and some sort of functions which we need for the overall machine learning algorithms. So what we're gonna do first function is simply to just report back your log loss, so that I don't want to keep on writing this code again and again, because we are going to build various model like naive Bayes, Ken, and logistic regressions and so on. So I don't want to keep on repeating the same functions, same code again and again, and that's the whole reason we are writing it up. Second is plot confusion matrix. And if you do recall, this is exactly the same code which we had already seen it earlier when I created random basically model. So what I have just done, because we have to do create it again and again, now I created a function for it so that we can again and again recall it. And the role of this function would be that it's gonna give you back your precision, recall, and your accuracy, means your confusion matrix. So all these three matrix it is going to return, and if you look at it, exactly the same code. You can see that we have A, B, C, and these were exactly the same thing what we had created here. And the same function I'm going to call it in predict and plot confusion matrix function. So you can see that I'm calling this function here, and this function is doing nothing but it's gonna help me to do my prediction part, because my prediction code is also going to be common for almost all the algorithms. So that's the reason it's better to create a function so that I can use it again and again. Now, further to this, this is the function which is required only for naive Bayes, so don't bother about it much. It's just gonna tell you for a given index, and it's gonna print that what is the name of that particular feature. Okay, and we will also check whether the feature is present in the test point text or not. So this is a very simple, straightforward function which is just gonna we can see that it's written in FL's loop, just to kind of look at and tell you that whether it's present in it or not. So we'll see in the naive Bayes part. Now the next thing is we got gene, we got variation, we got text. We have converted them to one hot encoding. We have converted to basically different sort of encodings here, right? We have done the imputation also, so with the response encoding, but here we need to combine the num. So we cannot just leave it as it. So let's say if A is one, basically this sort of value, B is this value, I'm gonna combine them, right? Just think of it like this. Let's say the first vector which you are seeing, this one, let's assume that this is your gene, right? And let's say this value is your let's say variation. So I have to combine them like this, right? I need to stack them so that, you know, now this column, then this column, so concatenate these columns. So that's what we are going to do here, and we can do it with the help of hstack function. Once we go ahead with this, so this is gonna just create this, and I'm gonna concatenate both the type of calls, one gene, variation, and text for response encoding, and one combination we will do for one hot encoder for all these three types. So once we have done this, you can look at it and we can get this particular output, and you can see the shape of this part. So you can see here that for the train data one hot encoding, when I got 56,201 columns, which is huge, right? Even my rows are lesser than the column number, and it's obvious because if you remember, my text column was having huge number of columns, and that's the reason in the final output I have this. But if I do a combination with the response encoding, I have only 27 columns, because 999 for each, and that's the reason we do have only 27 here. So we are done with this, and after this we're gonna look at building the machine learning models. So we got our data. Now we will start shooting with respect to naive Bayes as our first algorithm, and we'll keep on comparing the results with various algorithms and see how it works.